Okay, part 2 of chapter 1, section 4, the complex numbers. This time we're going to talk about the conjugate of a complex number. Okay, because if we have an I in the denominator, technically we really have a square root in the denominator. And so you have to eliminate the radical from the denominator by rationalizing it. And the only way to get rid of it is to multiply by the conjugate over itself. So just when you thought those types of problems went away, well, they're back. All right, so the complex conjugate of the number a plus bi is, what do you think? If you said a minus bi, you are correct. And the complex conjugate of a subtract bi is a add bi. Right? So the only difference between those two expressions is the signs in between. Now, any time that you have an a plus bi times an a minus bi, or vice versa, a minus bi times an a plus bi, it's always going to end up, the output's always going to be a squared plus b squared. Always. Okay, and I'm going to show you why it's always a squared plus b squared. You're like, well, wait a minute. Last time it was subtraction. Yes, you're right. It is. Because a positive times a negative is a negative. But I times I is I squared. And we saw up here that I squared equaled -1. And when you have a negative and you multiply by another negative, it's a positive. Okay, so it's always going to come out as a squared plus b squared. You must multiply any denominators by the conjugate when dividing complex numbers. We must get rid of the I in the lower level. Okay, so this is very similar to what we did when we were multiplying, how would you say, expressions involving fractions where you had radicals in the denominator. All right, let's look at some actual examples. All right, so example 3 says divide, and what we're going to divide is 5 plus 4i with 4 minus 2i. Okay, so technically here I have a radical in the denominator, and I need to get rid of that radical. The only way to do it is to multiply by the conjugate over itself. So I'm going to rewrite this problem, 5 plus 4i over 4 minus 2i. And I'm going to show that I'm going to multiply by the conjugate of 4 minus 2i, which is 4 plus 2i, over itself. All right, and these are quantities. All right, the denominator is always going to be a squared plus b squared. You know, your a is 4, your b is 2, right? Because it's a plus bi. Okay, so it's going to be 16 plus 4, which is 20. And you're going to see we're going to come out with that after we do some multiplication. All right, I'm going to extend my paper. And now let's FOIL. 5 times 4, 20. 5 times 2i plus 10i. 4i times 4 plus 16i. 4i times 2i. Well, 4 times 2 is 8. It's positive, so this is positive 8i squared. Now remember, you can't keep an I squared. You've got to substitute that with -1. This down yonder, well, this is 4 times 4, or 16. This is plus 8i, minus 8i. And then this is negative. 2 times 2 is 4. I times I is I squared. In the numerator, this is 20. This is plus 26i. Plus 8i squared. Well, I squared is -1 times 8 is -8. Notice these. These are opposites. They go away. They always will. That's why we do this, to make that happen. And here I've got a negative 4i squared. Well, I squared is negative 1 times negative 4 is positive 4. So this becomes 16 plus 4. Now I'm going to do 20 subtract 8 and get 12 plus 26i over 20. Now we have to be careful here because, you know, this isn't quite in a plus bi form, and your book is going to want you to do that. So this quantity divided by 20 really means 12 divided by 20 plus 26 divided by 20 times I. Here's my a plus bi. And of course, you always simplify your fractions. 12 over 20, 4 divides each of those. That's 3/5. 26 over 20, they're both even, plus 13 tenths times I. Okay, not difficult, but you do have to take your time and think about it so you're not making silly mistakes. Notice this expression no longer has an I in the denominator, right? Because I is really the square root of negative 1. We have to rationalize the denominator by multiplying by the conjugate over itself. So if you have any questions, you know, please ask in class. The next part of this is we are going to simplify some of these, just like we simplified radicals. Now, I am concerned because, you know, I have enough students that just are not mastering the simplifying of the radicals, and now you're going to have to do it with I involved as well. So I'm not quite sure what the deal is, if you're just not interested in it, if you just don't know your squares or your cubes. I'm not quite sure what the deal is, but we need to get that fixed. All right. Let's change the color. Let's see, what do I want to change it to? I'll change it to orange, I guess, since we're closing in on Halloween time. All right. First example is the square root of negative 27 plus the square root of negative 48. Okay? Now, anytime you see a negative inside the radical, you want to take it out right away. So I always say, like, poke the eyes out, okay? Halloween time, ha ha ha. Okay, poke the eyes out. So this becomes I root 27. Add I root 48. Now 27 is not a square, but 9 is. And 9 lives, it's a factor of 27. It lives within 27. And so we could rewrite this as I, 27 is 9 times 3, plus I, 48. I know 48 is 16 times 3 because I'm used to my squares. All right, now remember we did this before. You know, the 9 would come out as a 3, and over here the 16 would come out as a 4. So this is 3i root 3. And this is 4i root 3. And if I've got 3i root 3's and 4 more I root 3's, well, that's 7 of them all together. 7i root 3. Okay, so you kind of have to remember how to simplify the radicals. All right, the next example. Negative 2, quantity, plus the square root of negative 3. Take that quantity and square it. Now, folks, I recommend take I out first. Poke out the eyes. Poke out the eyes. Poke the eyes out. Take I out first. Okay, it's Halloween time, spooky time. Poke the eyes out. This becomes negative 2 plus I root 3 quantity squared. Now remember, how do you square a binomial? You square the first, you square the second, first times second, then double. Excuse me. So I'm going to square a negative 2. On the end, I'm going to write plus I root 3 squared. Then it's first times second, then double in the middle, so I'm going to do plus 2 times negative 2 times I root 3. Okay? You could FOIL, but it's more work. Square it, multiply them, then double. Okay? Square negative 2, you get positive 4. And hey, anyway, this, what I'm showing you how to set this up, this is college algebra. And so I do want you to learn these skills of how to go faster. This is why some are having a little bit of issues with not being able to finish a test or a quiz in time. Okay? I'm wanting you to do it this way so that it expedites it. All right? So here, I'm going to multiply, right? I'm going to cover these up. 2 times 2 is 4. It's negative. Don't forget about I root 3. So this is negative 4 I root 3. And then when I square this, notice what's going to happen. This is going to be I times root 3 times root 3. We'll write it out so you could see it. I times I is I squared. Root 3 times root 3 is root 3 squared. Or 3. Okay, so this is 4 minus 4I root 3. Now let's figure this out. I squared is negative 1. Root 3 squared is 3. Okay, so that number is negative 3. And my final answer, I've got a 4 minus 3, which is a 1. And then this minus 4I root 3. Final answer. And that's how you'd square a binomial involving a complex number. Okay, but always remember to take the I out first. Okay, another one. It's a fraction. I've got negative 14 plus the square root of negative 12. Yes, we're going to have I here. And in fact, we got to simplify 12. 12 is 4 times 3. The 4 comes out as a 2. Okay, so we're going to come down here. I'll put a little separator line there. This is negative 14 plus, we take the I out. The I always comes in the front. You never put it behind the radical because then we don't know if the I is inside or outside. If it's meant to be inside, then that's called a nested radical, and that's so much more work. We don't want to do that. 12 is 4 times 3, so this is really I times the square root of 4 times 3. And the whole thing divided by 2. Alright, so what do we got? We got negative 14. 4 is going to come out as a 2. So that's 2I root 3. It's addition over 2. Now this becomes a problem like this, where we have to split it. So it's in that A plus BI form. Okay? So I'm going to split it. This is negative 14 over 2 plus 2I root 3 over 2. And you have to simplify. This equals negative 7. Look, the 2's are going to divide out, and this is going to become I root 3, and that's addition. Folks, this is A plus BI form. Yes, you're right, I have the I in front of the radical. That's because we mean it to not be inside the radical. Okay? One more, straight across multiplication, but we're going to group it. 3 times the square root of negative 7. Multiply that with 2 times the square root of negative 8. Remember what I said. take I out first. Poke out the I's. If you don't, you're going to do negative times negative is positive, and you're going to lose that whole I. Okay? Don't do that. Take the I out first. This is 3I root 7 being multiplied with 2I root 8. But root 8 could be thought of as 4 times 2. Why am I writing it as 4 times 2? Yes, you're correct, because 4 is a square, and I have to simplify that radical 8. All right, this becomes 3I root 7. 4 is going to come out as a 2. And that 2 is going to get multiplied with this 2, so this becomes 4I root 2. But we're not done. This is 4 times 3, or 12. I times I is I squared. See, there's no pluses and minuses between. So, you know, this is not a FOIL thing. This is straight across multiplication. So I have to rearrange. 3 times 4, I times I. Root 7 times root 2 is root 14. You have to use that product rule. You're still not done, because I squared equals, you got it, -1. And so this, fully simplified, is -12 times the square root of 14. Okay? So they come with a little bit of practice. Please, when you're working on the assignment, check your answers. Okay? You got to check your answers. And if you're not getting the right answers, then you should have questions, because I believe in my heart of hearts that everyone who's enrolled in this course can do these problems. It's just, you know, will you sit down and will you do them, and will you put the time in, and will you take the time or the initiative to ask questions? So I'm trying to give you everything that I got between, you know, a Google Meet and between, you know, asking in class, or, you know, send me a message or post on that homework discussion. Okay, till the next time. Have a great day.